Okay, these are our notes on analyzing quadratic functions in standard form. Standard form simply means that we have everything on the same side. Ax squared plus bx plus c equals 0. And a is not equal to 0. If a were 0, then it would be a linear function. So we're going to look at some examples and all the different parts of it, and then we're going to look at the calculator, how we can find these different things. There's quite a few steps, and we'll go over them again, but I want you to listen and write the notes down with the places you're going to go in the calculator. That way when we look at them in class, then we'll be able to be looking at notes instead of you writing the notes. When we look at a function, first of all, the red lines here are our parent functions. So this one is our original graph for both of these. We've already talked about changes in our graphs, and so this one has an x added in the middle, so it's not just up or down, narrow or wider. It actually is going to move a little bit right and left. So if I take this and I make it and move it this way, it would be straight down. This is over to the side a little bit, and because of the 3, it's a little bit more narrow. Same thing with this one. The negative not only flips this upside down, it also has moved our vertex over this way, and the 1/2 has made it wider. So there's a lot of things that are going on here. This is how we were going to describe them. Whether they open up or down, that's determined by your A being positive or negative. The width, if A is greater than 1, it's going to be more narrow, like we talked about. If it's less than 1, it's going to be wider. Our y-intercept is your C. It's on the y-axis. Wherever you have C at, this, you can see from both of those. This one was a -5. That's our y-intercept down here. This one was at 2. There's our y-intercept right there. It's not the vertex necessarily, because on these, if there's a middle term, it can be a vertex, but it's the y-intercept. The x-intercepts are what we're going to get either from the graph or the equation. Same thing for our vertex. If it's right on the line, like we have -1, 0, then there's one of our x-intercepts that has to be on the x-axis. This one's not exact. I can tell that it's just before 2, but we're going to look at how in the calculator we can find out exactly that amount. Same thing on this one. Both of these are off a little. That one's a little past -8. That one is before 1. And so we're going to use the calculator steps to find it. For our vertex is either going to be a minimum. If it's the lowest point on our graph, it's going to be very important for our calculator. Or it's going to be a maximum if it's at the top of our graph. And again, that's going to be really important. One thing we can call these points, x-intercepts, are zeros, because wherever they cross, our y value is 0. And that's going to be real important in our calculator also. The other thing is our axis of symmetry. The axis of symmetry and the maximum are really easy. Axis of symmetry is going to be the x value from your vertex. Always. Whatever the x value is of your vertex, axis of symmetry means the line that goes right down the center. So if this is my vertex, there's a line of symmetry. Same thing here. This is my max. It's in the line of symmetry, so I draw it where it's exact. -4. So my line of symmetry is right there. What it means, symmetry, is that's where we cut in half our parabola, where you can fold it in half on the other side. Your max or min value is going to be the y of your vertex. That one comes from y. This one is our y. It's either the lowest value of your vertex or it's the highest value of your vertex. So on the back, we're going to look at some examples, and I'm going to use the calculator and plot some points, and I want you to follow along carefully. Okay, first of all, if we put this in the calculator, we can look at what the graph's supposed to be. 3x squared minus 2x minus 5. And if you haven't cleared a calculator, when you get back to class, then make sure you clear it so you're starting from fresh and you have your screen. If not, you can go from Zoom 6 and it'll reset your screen. So there's what our function looks like. If we wanted to put the parent function on there, we could put y equals x squared, but I want to leave our screen kind of free to look at this. Okay, we can use this button right here that's trace. And if I trace, it should go to the y-intercept each time. And then I can go from right to left. So I can get an idea of where my vertex is at the very bottom, down here, or my x-intercepts that are right around here. But we want to be exact. So first of all, I'm going to use 0, -5. I want to plot these points as much as I can. So the y-intercept is at 0, -5. So I know that I have one point on my graph here. Just to get an idea where our graph is, we could go to the table and you could look at exact points. But we want to look at our intercept and our vertex. So this is what we're going to do in the calculator. Right beside x-intercept, I want you to write zeros. That's what we're going to look for in the calculator. So we go back to our calculator. I want to trace, second key from the right, I'm going to trace to where I'm really close to there. Because our x-intercepts are the 2 points where it crosses the x-axis. I want to calculate, we're going to go to second and that same key trace. And I want to pick 2 for zeros. It comes up with a left-bound, right-bound thing. That simply means use your arrow key and go a little bit to the left of our mark. Second trace. Make sure you're on the point because it'll jump around. So we want to get as close to our point as we can. Second trace. Pick our 0. Hit left bound. Press enter. Go to the other side of the x-axis. Press enter. And you'll see these 2 little marks. We're looking for this right here because right in between there is where we want it to guess on our intercept. So we're looking for those points. Then I can just press enter and it will tell me that the 0 is at -1, 0. That's one of my points. So I'm going to hit trace, I'm going to go to the other side. Go as close to it as I can. Second trace. This is a 0, so I'm going to pick number 2. I'm going to go to the left, where it's just below it. Press enter. You can see the arrow that appears. I'm going just above my graph to the right. Press enter. You want those 2 arrows pointing toward each other up there at the top. This is what you're going to be looking for in your calculator. You need a left side and a right side to find the intersection. Then when we press enter, it tells me it's at 1.67 and 0. So when we go back to our paper, we're going to put those on here. Our intercepts, we had -1, 0, so it crosses right here. And we had 1.67, 0, right there. Then you can draw your line. Not yet. But one other thing, vertex. We need the vertex and you need 2 x-intercepts for you to have your graph. Okay, so for the vertex, we're looking for the point that's lowest on our graph. So we want to know what this point is. Press trace. Go down to this point. Get as close to it as you can. And then we're going to go second trace, same one, but this time we want minimum because it's the bottom of our screen. So we're looking for a minimum here. So I'm going to pick number 3. Same thing, left bound, right bound. So I'm going to go to the left, press enter. We're going to go to the right. Doesn't really matter how far, you just want to be on either side of it. Press enter. There's my 2 arrows up at the top again. So to guess, that's my minimum. 0.33, -5.3. So when I go back to my paper, we have 0.3, and negative 0.5, 5.3. So we have 0.3 and negative 5.3, so it's a little bit below, and then we can draw the line. This one's going to be pretty narrow because we have that 3. That's what our parabola is going to look like. The other two we can answer from here. 0.33, it's our axis of symmetry. That's the line that goes directly up the center of our graph. It's our line of symmetry. Obviously it opens up. And for our minimum value, we want this y value of x, of our vertex. So we have a negative 5.3. Okay, number 2 is going to be similar to that. We're going to wait and work on it in class, but I want to go ahead and look at number 3 because this is going to be going the other direction. So let's go back to our calculator. Go to y equals. We're going to put in negative 1 divided by 8x squared plus 6 and graph. Something you notice about this one, there's no x term in the center, so this is a little more like what we were doing before. We press trace. This is going to go to 0, 6. That point is our y-intercept. And because there is no x term in the center, that is our axis of symmetry. It's also through the middle. So our vertex is the same thing. If you weren't sure, you could do the left and right with the finding what our vertex is at the bound. Okay, so our x-intercepts, again, we're looking for zeros. And we're going to have to pick our left bound and our right bound for our intercepts. So go back to my calculator. I know that they're somewhere over here to the left, so I'm going to press trace. And I want to go down here to as close as I can on the left side. Second trace, this is a 0. It's the next intercept. I'm going to go just to the left of it, press enter. Just above it, to the right, press enter. Remember, we're looking for the arrows that are right here. They're going on either side of the point that we're looking for. And yes, we have negative 6.9. We go to the other side. It's going to be symmetric, so if you have it right in the center, wherever you're on the left or the right, it's going to be just the opposite. So we get onto the line here, and it doesn't be right on it, it's just be close to it. And do second trace, hit number 2 for the zeros. I want to go just to the left, always go to the left first. Then go to the right. Use your left and right arrow keys. There's my arrows that we're looking for. Find the point, press enter. And it tells me, it tells me 6.9. So the left was negative 6.90, the right is positive 6.90. Let me get rid of these lines so we can draw it. So if we go back to my paper, we have our intercept, negative 6.90, and this one over a little, and positive 6.90. So we're going to right here, and right here. And there's also that. You need to have your points, they may not be exact on your parabola. I know my curve's a little bit off there, but you can that we use as your guide, those points. I'm usually better at drawing those than I am. Our axis symmetry comes from our x value, so we have 0. This one opens down. And then we want our y value, which in this case is going to have to be a maximum because it starts at the top. So remember, if you're looking for an x-intercept, we're going to pick 0, and these come from second trace on your calculator. You want 0, which is number 2, for our intercepts. Let's say x-intercept specifically. And then for our vertex, it's either going to be a minimum or a maximum. And we need to be sure that we do the bounds from left to right. So whenever you get to your point, you trace over to it. Then go to your menu and pick a little bit to the left and a little bit to the right, and the calculator will pick that value for you. Okay, and those are some notes on the quadratics in standard form, and we will do number 2 in class. You can try it on your own and then check it when we go over.